Hi everyone, here is Dani Cajas, the creator of Riskfolio-Lib, one of the most popular portfolio optimization Python libraries around the world. Riskfolio-Lib has more than 500,000 of downloads and more than 3,000 stars on GitHub. Today I am going to present a new product related to Riskfolio-Lib called Riskfolio-XL. Riskfolio-XL is a Riskfolio-Lib add-in for Microsoft Excel. Riskfolio-XL is based on the Pixel library, so it requires that you have a valid license of the Pixel add-in. And the objective of Riskfolio-XL is to help non-programming users to build investment portfolios based on mathematically complex models with low effort, and also the sales of the Riskfolio-XL package will help the support, maintenance, and further development of Riskfolio-Lib. Riskfolio-XL is very easy to install. You only need to use this command pip install Riskfolio-XL. And when you download Riskfolio-XL, you will receive a trial copy of Riskfolio-XL. This copy is limited to work only with 7 assets and with 3 risk factors. You have access to all the functionalities, all the models, but limited only to 7 assets and 3 risk factors. Okay, if you, after you test Riskfolio-XL, you see that it's a good product and it meets your needs, you can buy a license for Riskfolio-XL. So we have the monthly license and the annual license. Okay, and after you pay, you can send us an email with your invoice to orange.eirl@gmail.com, and you will receive your Riskfolio-XL license and a discount code to purchase the Pixel package. Okay, when you have your Riskfolio-XL key, you only have to pay it into the Pixel configuration file. And here we have some screenshots that shows how you can paste your Riskfolio-XL key. So you have to open here in About Pixel, then click on the configuration file, and finally write your Riskfolio-XL license here in the Pixel configuration file. Okay, so now we are going to start with a small example that shows how to use a Riskfolio-XL. So to work with the Riskfolio-XL add-in, first we need to download a database of prices. In this case, we can use the function rpload prices. The download prices from Y Finance. The first input is this list of tickers. Then we use an start date and an ending date. And this way we can download a database of prices. Okay. Then we can calculate a database of returns. Also, we can change here the amount of data. Here the prices starting in 2020. You can see that are like 100 to 1,200 observations. Also, we can calculate here the returns. The next step is to calculate the returns using the function calculate returns. And the first input is a data frame of prices. Here, because the objects from the Riskfolio-XL add-in are tables, we can use the char character. And if we use only the data frame of prices, we calculate the arithmetic returns of the whole database. But also we can filter this database using this function. For example, we can select just a group of the assets, Also, we can change the initial date. Here, we can change the initial date. Also, we can change the frequency of the returns using any of the pandas date offset strings. So for example, here we can change the returns to weekly returns. Here we have the weekly returns. Here the difference of the dates are 7 days. And also we can here we can change the arithmetic returns to logarithm returns, changing this value from true to false. In this case, because my computer is in Spanish, I am going to change this value to falso, that is false in Spanish. So here we have the logarithm returns. So these functions allow us to calculate the returns in the frequency that we want, also filter the database of prices. So you can have a big database of prices and then you can calculate the returns in the frequency that you want. Okay, but because in this example we are going to work with the 25 assets, here we are going to delete this. And then we have here the full database of returns. Okay, now we are going to start minimizing the building a portfolio that minimizes the standard deviation of the variance. To do this, we are going to use the function rp min risk optimize. The first input of these functions is a database of returns. In this case, we select here the first cell and we add the char character. Then we are going to pass the inputs to the functions, for example, how to calculate the vector of expected returns, how to calculate the parameters of the calculation of the covariance matrix, also the optimization parameters. These are the parameters related to, all these parameters are related to Riskfolio-Lib, and the additional parameters, other parameters, that are other parameters from the Riskfolio-Lib library. Okay, and then we select and then we press here OK. And this portfolio is the portfolio that minimizes the variance. We can plot here, we can plot the composition of this portfolio, selecting here the first cell and adding the char character. Here we have the optimal portfolio that minimizes the variance. Also, for example, we can minimize the C-bar, the conditional value at risk. We can minimize the entropic value at risk. In this case, we have an error with the entropic value at risk. Maybe Laravel is not a solver that can solve this problem. So we can change to Mosaic if you have a Mosaic installed in your Anaconda distribution, or well, in your Python distribution. Also, we can change here the objective to sharp. Here the return divided by the entropic value at risk. We can change here to the variance, to the portfolio that maximize the return divided by the volatility. Also, we can go back to Laravel, that is an open source solvers. The problem with open source solvers is that sometimes they can find the optimal solution because the problem is a little too complex. Also, here we can allow the short positions, changing this parameter short to true. In this case, true in Spanish is verdadero here, and this is a parameter with short positions. Here we have parameters that control the maximum position per short position per asset, the maximum weight per long position, also the budget of the short positions. We can change this budget to 0.3, but in this case also here, and now we have a 30%. The weights of the short positions, and also you have other parameters that you can use to play. Okay, also you can have here change this to EUMA1 estimator to use the exponential weighted moving average of the vector of expected return. Also here the exponential weighted moving average of the covariance matrix here. So you have several parameters that you can use to play. And also in the here you have two buttons to see the documentation of Riskfolio-Lib to know the parameters. So you can check here in Optim Portfolio Models. You can check here what is the meaning of each parameter, because are the same parameters that the parameters used in Riskfolio-XL. Also, you can click here and you are going to open a folder with several examples of the functions of Riskfolio-XL. There are examples using classical optimization to calculate the efficient frontier, factor models, Black-Litterman with factor models, risk parity portfolios, hierarchical clustering portfolios like the hierarchical risk parity, optimization with network constraints. Also, all the plots, for example, we can open this. Well, the examples are based on the trial version. So we are working here with a database of 7 assets. Yes, 7 assets here and 3 risk factor. And well, here we have all the plots from Riskfolio-Lib using functions. So you can study and the parameters related to these functions. Okay, because these functions the plotting functions has some additional parameters. Okay, so you can check. And the same for the other examples. You have a lot of examples that you can check. So I hope you have enjoyed Riskfolio-Lib, Riskfolio-XL, sorry, and also you enjoyed the open source version that is Riskfolio-Lib for Python. And if you have any questions, you can write me or send me a direct message through LinkedIn. And that's all. I hope you have enjoyed this small presentation video.